Okay, welcome back, ENG 360, listing 1.2. This is part 3. I wanted to do a couple more stuff. The last video ran a little long, but I wanted to show you a few more things. In listing 1.2, what we did is we used an SOP approach to implementing a 2-bit comparator, right? We're going to compare A to B, and both those guys were 2 bits. Okay, and then we used an SOP implementation. We just looked at the truth table, 4 min-terms, and here are my min-terms, P0, P1, P2, P3, and then we ordered them all together to get the output. Okay, now that's eq2.vhd. Then I created a test bench file, tb eq2. All right, let's look at that. Well, when you look at that guy, we stubbed out a bunch of code, but basically you have a declaration of the component, and then the test bench has variables that mimic the component you're testing. And I prefixed them by TB, okay, to indicate that they're part of the test bench file. And then in the begin-end block of your architecture, first thing you do is instantiate. And then you have a process down here that executes. Now, because I put a process there just by itself, it's going to execute over and over and over. And what I do is I just run through the truth table, 0000, 0001, 0010, 0011, 0100. So I'm counting from 0 all the way up to 15. And after each one, I wait 15 nanoseconds. Okay? And I go down here all the way to where I get to 1110 and then 1111. And then notice the statement down here. If I don't have that statement here, then it's going to end the process and it's going to go all the way back up here and just repeat this process forever and ever. So you need that wait statement at the end to suspend it, and that way you can zoom to full view and see your waveform. Okay, so let's go ahead and simulate again. All right, let me select the component I developed. Okay, and okay, it looks like it's I've got a green check mark on check syntax, so you can run it again. You can right click and say rerun all and run it again, but you don't need to because you have that green check there. Then I select test bench EQ2. Again, I don't need to check the syntax on the test bench, but I can if I want to. Right click, rerun all. Make sure the test bench is selected and then simulate. Okay, we did this last time, right? And what we got was something that looked like this, right? There are my 3 test bench variables, okay? And there's my waveform, and let's zoom to full view. And there you go. Yeah, so I get an output here when both inputs are 0. I get an output here when 0, 1 and 0, 1 are on the inputs. I get an output here when both inputs have 1, 0. And I get an output here when both inputs have a 1, 1. Now notice the crisscross right here. Well, that means that data bus, which is 2 bits, is changing values. Now if I come up here and I click at the level of TBA, and then I right click and I select radix binary, okay, it changes those values from 0, 1, 2, 3 to binary. Okay, that's kind of good. And then if I click at the same level on TB2, right click and do radix on those guys, it'll change those to binary values. All right. So now at this point, you can kind of see when I click right here, I get 0, 0, 0, 0. Here I have 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. Okay, and these are my test bench variables. Okay. Here you've got 0, 1, 0, 0, 0, 1, 0, 1, output asserts, 0, 1, 1, 0, 0, 1, 1, 1. 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, output asserts, 1, 0, 1, 1, and then the last case, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and then 1, 1, 1, 1, output asserts. Now these are the variables of your test bench. You can click this little arrow right here and you can kind of see the individual variables. Here it's counting 0, 1, 2, 3. Okay. Down here you can get the individual variables. They're both 0, 0, and then underneath here you have 0, 0. Here's 1, 1, you have 1, 1. So you can see the individual bit streams. If these were 32, you could open them up and get 32 values. Okay? But these are the test bench files. Now come back over here and open up this guy. Okay? Notice what I did. I opened up TBEQ2, and then I've got this thing called UUT. Okay? UUT. Where'd UUT come from? Well, let's go back and look at our code. This is the test bench file right here. And notice, UUT. What is UUT? That's the name of my instantiation, my name of my instance of EQ2. So UUT corresponds to my instantiation of EQ2, which has variables A, B, A, E, Q, B. Right? So let's bring up the simulator again. Let's select that UUT and say right click, add to wave window. All right, so what it did, it added a bunch of stuff. The first three ones, TBA, TBB, and TBAEQ, are part of the test bench. But now these guys down here are variables that are part of the component. A, B, AEQ, P0, P1, P2, P3. So it has my inputs and my outputs, plus it has my internal variables that were declared in the declaration section of the architecture block. So we need to rerun this guy. So what I can do here is I can say restart, run, zoom to full view, and look what we've got here. Now, remember when we instantiated this guy, we took TBA and we mapped it to A. Well, notice TBA and A are the same thing. If I right click and change that to binary, and then let me do this one to binary. Yeah, TBA is the test bench, and we're connecting that wire to A, and those are the same values. Well, TBB, we're connecting that wire to B. Those are the same values. It makes sense, passing them straight through. Now, the output of my component, which is right here, gets connected to the test bench output, which is right here. Those guys are the same values. Okay? And then here are your intermediate product to sum terms. Notice P0 gets asserted one time, P1 gets asserted one time, P2 gets asserted one time, P3 gets asserted one time, and then when you OR all those guys together, you get AEQB, which is the ORing of those. You get 4 assertions when the A and B input bits are equal. So yeah, so the first 3 variables are part of your test bench, but then the last 1, 2, 3, 4, 5, 6, 7 are part of your component. But the cool thing about it is the first 3 are inputs and outputs, and then the other 4 are actual variables that you declared in part of your architecture block that were neither input or output. They're internal variables, but you can kind of see them here. All right, that's what I wanted to show you. So we'll stop there, and that will conclude listing 1.2. Thanks for watching.